right. Today I am visiting an old friend. This is a guy I first knew him when he was still in school. He is definitely not in school anymore. He's ripping up the place. His name is Jeff Snyder. We actually visited him for the first time back in podcast number 34. We had a great talk then about his background coming up through the system in Columbia and developing what at the time was my favorite control surface, which was the Snyderphonics Manta. Well, the Manta still exists. It's in a version 3. He's also come up with some new products. He's got some other stuff cooking in the background I think I can hear. So with that, we'll say hello to Jeff Snyder. Hey, Jeff, how's it going?
Hi, Darwin. How's it going?
All right. Thanks a lot for taking a break and having a chat with me. I appreciate it.
Yeah, definitely.
If people really want to know about your background, I'm going to ask them to head back to your old podcast number 34. That'll be a good shout back when I was like, I don't even think I'd gone through puberty yet. I had that really high voice. It was really pretty. What I do want to do is kind of get caught up on what's gone on since then. I mean, back then you had the Manta out for a little while, and you were just about to, I think you were just about to start a new job at Princeton, or else you had just started it. But
I think I just started, yeah.
Just started, okay. Well, what's been happening since then?
I'm still working at Princeton. My job has changed a little bit. Now I'm director of electronic music there, which is really nice. I teach the electronic music classes, and I run this thing called the Princeton Laptop Orchestra, also known as PLORC. So that takes up quite a lot of my time. And then I've kept going with Snyderphonics. That's my company making weird electronic musical instruments, while also trying to keep up a career as a composer and improviser. So that's just what I do these days, are those things.
Right. Do you leave yourself any time to sleep at all?
Yeah, sometimes. Yeah. No, I really like sleeping, so yeah.
So let's start off, before we get into talking about the Snyderphonics stuff, let's talk a little bit about the Princeton stuff. So Director of Electronic Music, that sounds pretty interesting. How does electronic music fit into the general music, the general area of music study? I think that it has always been kind of like this weird second cousin in most music environments. And I'm just wondering, in the case of Princeton, where does it kind of sit?
Generally in academia, I feel like more and more it's becoming sort of less the random second cousin that might be there or not, and more the necessary part of music education, right? I've definitely seen that happen even since I was in grad school more and more. Princeton is unusual because, which you may know, it's got a long history.
It's got a hell of a history,
yeah. That goes back into the 50s. There was something called the Columbia Princeton Electronic Music Center that was set up. That was really the first institutional electronic music center that really was working on research in what electronic music could be. So it's pretty exciting to be working here where there's that kind of tradition going back so far. RCA made this giant synthesizer called the RCA Mark II that the Columbia Princeton Electronic Music Center bought, and they installed it and figured out how to make all kinds of crazy stuff on it. And then after that, that was kind of the early period, is late 50s into the 60s. Then they got a Buchla synth, and they started doing really interesting things with that. And then eventually, like by the time the 80s rolled around, there was a lot of work it was at the forefront of digital music. So Paul Lansky was working here at the time and kind of developed a lot of really interesting digital music techniques that I think were very influential. Then, I don't know, into the 90s, Dan Truman was doing, he's still here, and he was electronic music pioneer in a lot of ways. Have you interviewed Dan Truman yet?
I have. He's a fascinating guy.
Yeah.
More energy than practically anyone I'd ever met.
That is definitely true. So, and he's actually the guy who started this laptop orchestra thing, which I now have taken over directorship of. So I don't know. I feel like, and the laptop orchestra idea, there's a lot of predecessors to it with the Hub out on the West Coast back in the 80s. There were some groups in Europe that were kind of similar to this concept, but the whole sort of American academic laptop orchestra thing has kind of come into existence based on this Princeton model, which is kind of exciting. So it's had a lot of influence. In Princeton, I feel like due to that, there's a relatively big presence for electronic music, and it's not something I have to argue too much about whether it's important or not,
Right.
Which I think a lot of academic colleagues in other institutions maybe do.
Yeah, I think they do, because a lot of times I think people will be willing to have an electronic music thing as long as it ends up looking like a music technology thing.
Exactly.
Right? Which that's where maybe some of the history that Princeton brings to the game prevents it from falling down that hole.
Yeah, it's always been traditionally at Princeton, it was in the realm of the composers, where Milton Babbitt sort of initiated this.
Right.
And then in the 90s, there was this real connection between computer science and the music department when Perry Cook was here too. So I feel like there's always been, it's always been about people doing creative things with electronics rather than sort of more recording engineering kind of things.
Right.
Not to say that recording engineering can't be creative, but as in, more the creation rather than in terms of the support of it. Right.
Right. So how intimidating is it being the director of electronic music when the people that preceded you were like Truman and Lansky and some of these just like jaw-dropping people in history? How intimidating is that?
I don't know. I guess I don't feel too intimidated because I'm just kind of doing my own thing with it. So I guess the thing that I feel like the challenge is how do I keep electronic music at Princeton at the forefront in a way, right? Or how do I keep us always doing new things? Right. So I see that as my responsibility, really. Like, how do we make electronic music at Princeton always kind of be really interesting and not just fall into whatever we are used to doing? But luckily, I kind of feel like that's what I'm most interested in doing anyway, is always something different than what I was doing before. So I don't know. So for me, it's not too stressful. I think I've done okay so far.
Yeah, that's interesting. Well, and it's kind of wild though to think of like needing, wanting to keep things fresh and wanting to keep things moving forward, when in a way you kind of have this responsibility to kind of uphold a tradition. I mean, at this point, the PLORC has the Princeton Laptop Orchestra that has to feel like there's not only the opportunity to do something interesting, but there's also this tradition of what it was and maintaining that. How do you take something that is kind of that sealed in a spot in history and allow it to change and grow and evolve into the thing it needs to be now?
Yeah, that's a good question. I feel really lucky in the situation that I'm in that Perry Cook's retired, but both him and Dan Truman's still super active and we're colleagues here, but Dan Truman's kind of like, he does not care about laptop orchestra retaining any kind of tradition of what it is or having a repertoire that continues, he just kind of wants it to be whatever it should be at that moment, right? I felt very relieved when he kind of expressed that to me, that he's like, laptop orchestra should just evolve however you think it needs to evolve, right?
Sure.
And that's been good for me because actually I think if you asked me, so I started over here 8 years ago, but I sort of have, my positions changed a few times, and I've been directing the laptop orchestra alone for 6 years now. I feel like I never really get bored with it because every year it's a different group of people and I'm working on different research projects, and it's like, okay, who's got cool ideas? What are we going to do? And really, I don't think too much about like redoing repertoire or trying to keep anything the same or keep any kind of continuity. I basically just throw that away. So one thing we have that's a little bit of continuity that's helpful is we have some physical infrastructure, which we don't have to use, but it's handy, which is that we have these little hemispherical 6-channel speakers that can be kind of little independent individual sound systems for everybody.
I was wondering if you were still using those, because that was sort of like one of the visual components of the original laptop orchestra was those hemispheric speakers. I mean, it's sort of like you'd see people kind of like kneeling in front of their laptop with those in front of them, and that was sort of like the indicator that's like, oh hell, this is something new.
Yeah, we're still using them for sure. Right now, I mean, the real advantage of that kind of system is basically just the advantage of when you have a whole bunch of computers in a room, if you're using computers, and you want a bunch of people playing together with electronic sound, if you all go into a PA, it immediately becomes impossible to tell who's doing what.
Right.
So having individualized sound systems, I think, is the most important thing in that world, once the number of players gets high enough. But also just, the hemispherical thing, I think, is a more subtle thing, which is just, it's really nice to have individual amplifiers that aren't like a beam the way a guitar amp is, and that goes to the player's ear, but also goes to everybody else in the room's ear in a way that gives directional cues, so everybody can improvise together and know that, oh, this person's making that sound, right? And it becomes not something you have to think about, because you can just tell who's doing what.
Sure.
So that's really nice. But we don't always use those, it's because they also have downsides. It's basically 6 car speakers on a little case, and doesn't have that much bass response, so we couple them with a little subwoofer. But really, if you're choosing between that or hooking to a sound system that has an amazing subwoofer or something, sometimes it makes more sense to go to house sound if we have a small number of people, or maybe we want to do something with spatialization around the audience, but we want to be on stage. There's also all kinds of situations in which we just have to say, okay, what's the right tool for this job?
Sure.
But we end up using those Hemis all the time in rehearsal, and it's fantastic. We call them the Hemis.
The Hemis.
The hemispherical speakers. Yeah.
Right.
There's one of the people who originally developed the Hemi speakers with so it was Dan Truman, Perry Cook, Scott Smallwood, and Stephen Moore kind of developed them together. And Stephen Moore has started a little company selling them called Isabel. So you can buy your own hemispherical speaker thing now, which is kind of cool.
Right. Very interesting. Now, so in the time that you've been working with them, what has actually changed other than the repertoire? What have you had any equipment changes? Has there been changes in the software that people generally use or compose with or compose for? Are you seeing any changes along those lines?
I wonder. Basically just a lot of things change all the time. I'm trying to think of what's consistent more. I tend to work in Max MSP, and Chuck are the 2 music languages that I work in. So a lot of the patches that I develop, and I also teach both those languages in my electronic music classes. Okay. So a lot of work that comes directly out of the ensemble tends to use those languages. Sometimes the grad students are coming in, Super Collider, so we get a lot of pieces in Super Collider too. But basically, one thing that's been consistent is we try to use free software all the time, because when you have 10 people on their own laptops, you can't distribute any kind of software that requires a license easily and perform with that. So basically, I mentioned Max, and that's not free software, but you can at least run Max patches on the runtime,
right?
Yeah, on the runtime. So I don't know. I'm trying to think what also has had the most change. I've been just building a lot of different electronic musical instruments as part of my research. So every year we just integrate those in different ways. I made a little percussion interface that I call the drum box that we debuted in a few Plurk shows. What other things? This year I made an instrument called the feedback trombone that kind of grew out of a research project along with a trombonist student who was also a physics major here. And I wrote a piece that included 3 feedback trombones along with a normal brass section. So I think we've moved a lot towards sort of more experimental instruments and just not taking the name laptop orchestra very very literally, right?
Right.
So I just kind of treat it as an experimental electronic music ensemble, where sometimes there's not even electronics. We've done pieces that are acoustic that just happened to, that's what we felt worked best for this piece or something, right? So I sort of think of it as it's an excuse to get on stage and try to do something experimental, really, or like try to do something that you haven't seen done before, really.
Well, and if you think about it,
Kind of
it's also sort of an opportunity to work with sort of like computer programs that are by, almost by definition unable to be synced, right? And so it's a different thing than working within a single machine.
True.
It's very much a different interaction model, and it's pretty compelling.
I think that's the most interesting thing about it. I think if you'd asked me, like, would you be interested in directing a laptop ensemble 8 years ago before I took this job, I would say no. Because the idea didn't really sound that exciting to me. Like,
Sure.
Oh, okay, a bunch of people on computers, maybe they got a network, and maybe they're typing. It looks like they're checking their email. I don't know, but like, really, the thing that's interesting about it is if you kind of step back from that and step back from any kind of preconceived notions you might have about what that might mean, and really think about it as, okay, we're going to make music for people that are using electronics. And it's a matter of, what if you wanted to make electronic music with more than one or two people, which is, when you're doing it with one person, you're working within one machine, or maybe you have a set of hardware or whatever. But yeah, you've got all these easy connections between software. But once you get a lot of people, the challenges get larger. But also you get musical interaction between those people that you can't have as a single person or as two people. And I think you just don't hear those types of interactions with electronic sound as much.
Right.
So to me, that's the interesting thing is like, what do you do with a bunch of people if you all want to make electronic music together? That's difficult.
Well, that's also kind of a really interesting compositional landscape because, when you're talking about computer musicians, each one of these people can make all the noise.
Exactly.
They can fill up 100% of the frequency space and then some. And so finding
a way... they can all sound like anything, or, right. It's like, you don't have these delineated roles necessarily, and you have to work to carve out the space, right?
You mentioned doing some instrument design as that some of these things do, and the way that we first met was you were in school, but you had made the first version of the Manta, which is this beautiful metal surface that has a very unique touch interaction. It's hypersensitive, but very musical. It's a beautiful piece of work. And you've continued to work on that. I just got the most recent model, which is, you said it's a Rev 3, right?
Yep. Yeah, 3rd edition.
Yeah, and so it feels different. It remains beautiful. What has changed in the revs, and were the change required by like differences in parts or manufacturing, or did you just come across different ideas? What led to the changes?
I think possibly the most striking thing about the Manta is that it hasn't changed much in 10 years. I came out with the original one in 2008. When you think about sort of electronic musical instruments, I feel like a lot of things end up falling a little bit on that gadget spectrum of feeling like it needs to update and constantly be different in order to make the old thing obsolete. I mean, right. A lot of the great electronic music designers today don't do that. But if you look at, I don't know, Apple devices and things like that, like the general consumer electronics has that planned obsolescence thing.
Right.
But also, and also just this idea of, it's not finished, we're going to, it's always going to develop or change. And part of the Manta for me was I did a whole lot of iterations before I came out with the thing as a product. So I went through all sorts of different sensor designs, and originally maybe it was going to have a piano keyboard style thing, and now it's like a hexagon grid. And I just experimented with all different sorts of sizes of sensors and positioning of things, and, how many sensors are there, and how big is it? And originally it was like 2 of the things that is now called the Manta, and they were like hinged together, and it went through tons of design iterations. But then once I came out with it, I was kind of like, okay, this is the thing. I only made one major change to it since then, which is when it originally came out, it had a single color LED behind each sensor, touch sensor, that glowed amber. And at some point, I got really kind of interested in the things that you could do by controlling with a computer, LEDs being decoupled from the touch sensor. I definitely was influenced by the Monome and going that direction.
Right.
With like, what can you do with sort of dynamically controllable grid lighting as an interaction paradigm? And I realized how much having a single color limited that. So I could have gone one really far and been like, okay, well, I'll make them RGB LEDs and you can get any kind of hue you want, and then it can impart all this color information. But I kind of wanted it to retain a really strong design aesthetic, and I didn't want to go too far from the aesthetic it already had. So I added a red LED along with the amber LEDs. And I feel like that gives it enough extra ability to impart some more information, but it really keeps it inside the design aesthetic I wanted. It feels like it's like kind of, maybe like glowing fire inside the thing, right? And I really made no other physical obvious changes to the user. I did a bunch of stuff inside in order to make the other LED traces able to go around. Functionally for the user, nothing really changed. And actually in the third edition, functionally for the user, almost nothing changed whatsoever. Because I just made some slight iterations to try to improve the power supply system, because I realized I was kind of had some leads that were too thin for certain, dropped the current a little bit too much from certain computers.
I see.
Going over USB, and some power supply things made me say, I should try to switch this up. But there's other little tiny details that changed, but those are all mostly driven by manufacturing issues. So you asked a little bit about that. I don't know.
Like, one of the things I noticed is it seemed like the surface of the metal was slightly different.
Mm-hmm.
Not a lot different. I don't know. Is it polished different, or is it?
Yeah, that's definitely something I changed. So after the first edition, the surface itself is just a printed circuit board, basically, used as a cosmetic and touch surface. So it's these capacitive sensors, but really, like, the circuit board is the panel, and all the components are on the back of the circuit board. So that means that the fabrication technique I'm using is I'm getting normally a circuit fabricator to make this thing that becomes the final panel.
Okay.
And they're not used to thinking about things as cosmetic, right? So like a circuit board, a PCB surface is not considered a cosmetic surface for engineering purposes, right? So I would get them back from the manufacturer and they're functionally all worked, but then like some of them would look really grubby, or have sort of smears on them. It's just like, and they had kind of a patina on them already in a way that didn't look like a new product would, right?
Right, I see.
And originally I kind of was like, okay, that's the look of the thing, because I kind of liked it.
Well, it's kind of steampunky almost. Yeah.
Exactly, yeah. It's a little bit, it gives it this sort of like, oh, it's already old, or, But then I got a lot of comments from people buying it being like, this doesn't look like I'm used to a new product looking. So then I experimented a little bit to see what I could do to polish them up after I get them from the fabricator. And now I just use, every time I ship one out, I use a metal polish on it. I found one metal polish that doesn't smell as horrible as all the other ones. Right. And I give it a bunch of elbow grease and just work on them now. But it adds labor to me, but I feel like it actually looks really nice when they're polished up. So I sort of wish I'd done it from the get-go, because it's pretty fancy looking.
Yeah, it is. It's amazing. Now, the piece that's now paired up with for me is another device that's new since we last talked. I mean, completely new. And that is a Eurorack module called the MantaMate. Now, the MantaMate for a long time was sort of like the white unicorn, right? It was something that was talked about and imagined. And I think at any point in time, anyone who's kind of intrigued by the Manta had like a mental image of what the MantaMate could be.
Yeah.
But now it's real. Why don't you talk a little bit about what exactly it does and what it can do?
So I finally finished this thing. I've been working on the MantaMate since 2010, so it really took me like 7 years to come out with it. And I wasn't working on it nonstop like I should have been, but I had another job, obviously. So the main thing about it was I'm actually I'm an analog synth user, and that's been my main instrument since like 2007. So pretty immediately after I made the Manta, which is originally a USB device, it communicates with a computer, I was like, oh, I wonder how I can make it so this thing can talk to my modular synth. I started working on that, but it was a little hard at the time to figure out how to get a microcontroller to act as a USB host, which is a little more difficult than just having it be a USB device. And I experimented a little bit with that kind of thing. And eventually I made this little thing that it's a module, you can plug the Manta into it, and it'll have a lot of functionality. You can use the Manta as a keyboard, and it'll come out with voltages that give you, can be pitch and gate and velocity. It's got some sliders on the Manta, and they'll come out as different outputs. And that was the main kind of vision of sort of what does it need to be at the minimum, right? Was like, You should be able to plug the Manta in. You should be able to, so the Manta, each sensor sort of gives an output of how much surface area you're covering. So it's kind of like a little keyboard, but with touch sensitive keys, basically. So I was like, okay, you should be able to plug in your Manta into your modular synth through the MantaMate, and it should allow that information to come through in voltage control, right? And every version that I've developed of the MantaMate did that, but I've just been working for a long time trying to figure out what else it should do or what its character should be beyond that. So it ended up doing a whole lot of other things too. And maybe that's part of the issue with getting the word out about it in general. I've been having trouble figuring out how to get people to understand what it is that it does a lot. You can plug in the Manta, it can be a keyboard, but it can also be a sequencer. So you can it turns this Manta controller into a touch sequencer where all the hexagons can be steps in the step sequence, and you can touch them to activate them. You can change parameters of each step, make it have a pitch associated with it, make it have certain slider values associated with it. It also acts as a USB MIDI host, so you can plug in a standard MIDI keyboard into the MantaMate instead of a Manta. You can plug in a joystick or a gamepad into it instead of a Manta, and it'll just route those XY values and buttons out the CV outputs. You can actually use it without any device plugged in whatsoever, and it'll be a clock generator or a clock divider or a random voltage generator or a random pattern generator. I built in a whole bunch of functionality that, for me, makes it really handy to be sort of the center of my studio.
Right.
I'm not sure how many other people care about it doing all those things, but but for me, it's been really handy to have just one 12 HP thing that can handle, you can also plug it into your computer, and then it just shows up as a MIDI device, and you can send MIDI from your computer to it. So it sort of does a lot of those things all in one.
I guess in some cases, I mean, it sort of has the Swiss Army knife issue, which is that if what you need is a bread knife, you look for the bread knife first.
Yeah, you don't look for the Swiss Army knife.
Right.
Yep.
But the flip side of it is, well, I'll say this. The first time I had it plugged into my system, and then I plugged the Manta in, and the Manta lights up in this kind of keyboardy configuration, and I get voltages coming out of those little sliders, and I get octave shifts and stuff like this. It seems magical. It's pretty amazing because the combination is really compelling, both visually as well as just the touch. Again, I've always loved the touch of the Mantas anyway, but combining that with the modular system is particularly exciting because now all of a sudden these touch parameters, you get that routed to 5 different things, and it sort of makes the modular come alive. It's a lot of fun.
I feel like it really lets you get your hand on those signals in a way that I found very difficult to do with any other way to control my modular, right?
Right. But then the other thing for me is that it's also convenient. Sometimes I just need to play in a damn line. I need to play a C minor line over 3 octaves, and it's just inconvenient to do that with anything except a MIDI controller. And it's really convenient to just plug in the damn M-Audio MIDI controller and blurt out a line when I have to. And so while I recognize that your focus has always been on the Manta's connection to it, it is really kind of nice to have that. I've actually ordered an old Nintendo style gamepad just simply because I want to experience with that, what it's like doing with that. Now, the one thing I haven't yet played around with is the not plugged in at all version.
Oh yeah,
which is pretty fun.
Interesting.
Yeah,
that was like an afterthought. Basically, I added that firmware. I programmed all of that, all of the no device functionality. I programmed in a week over the summer, right before I released it. Maybe a month before I actually started shipping them. And it was really just because I'd done all this other functionality, and then I was I'd been working with it that summer and just kind of using it as my main rig in my studio. And I just got frustrated that whenever I didn't want a keyboard controller or, didn't want it plugged into my computer or something, it just did nothing. So, and it was just wasting space. And I was like, I kind of wish that when I didn't need a controller, it did something, since it has all these jacks, it has a bunch of outputs, has a clock input, I might as well make it do something. So then I tried to think up all the fun things it could do without all the things you could do with 12 outputs and one digital input without any knobs or any control voltage inputs.
Right.
It's like, what are those things? So I ended up sticking all that stuff in, and honestly, I use that function all the time. Probably other people, maybe there's definitely a lot of different modules that do a lot of the jobs that no device mode of the MantaMate does, but it's kind of nice to have them all in one device.
Right.
Especially the one that turned out to be really exciting to me is very simple. So I started out, I made kind of a thing where every time it gets a clock, it just randomly flips the outputs, right? So it's like basically gives you 12 or technically 11 random outputs that go on and off. Okay. And every time a clock comes in, they flip, right? And that's the first, one of the first presets. But then I like that, but randomness, pure randomness is never that interesting, right? It's like, you get a bunch of random values and you can get that really classic, kind of random patterns, but it's not really interesting until it repeats in some way.
Right.
So I set up a sort of repeating randomized thing where every time you boot it up, it generates a pattern of a certain length of random on-offs for every output. And then it loops those in that pattern length, right? That's just super fun because now it's like, okay, you got 11 little outputs. You can plug one into a snare drum, make one control sort of a bass drum thing, one control a hi-hat, and then you've got a really cool little randomized beat that actually loops. And then I have controls that let you set how long is that loop length, so you can make it 32 steps or you can make it 16 or 7 or whatever. I just mess with that for hours. It's super fun.
Now you've given me another thing to waste a night on. I can't wait.
You gotta check it out. It's really fun. The thing that really pushed that over the top for me was I set up I was like, okay, this is cool, but I don't want to have to turn it off and on every time I want to randomize. Right. So I put a little button press that lets you randomize it. But then I made another one that's called subtle randomize, which just kind of nudges it a little bit and changes some things.
Sure.
And that's really fun too. So it's like you can just basically make a drum beat and then be like, no, let's change that a little, and then just keep it kind of inching around. And now the snare drum's like a 16th note earlier in this one beat, or it's really great, especially for rhythmic patterns. I've just found it to be really, really exciting. But I found that really interesting that came out of it, because really that was never in any of my design plans for this thing, and I've been working on it for, as I said, like 8 years. So,
well,
I never said, oh, it needs to do this.
I mean, you mentioned mono. One of the things that I also find interesting, both with what you've done with the MantaMate and what Brian Crabtree's done with the mono modules, is this idea that you started off with a surface and then only later put together the hardware that would run an application. And I'm wondering, how hard is it to say, or to go through the process of saying, I'm going to take this thing that is limitless,
and make it limited
make it limited in some way.
Mm-hmm. It was super hard, and that's why I didn't come out with it for so long. So I should send you an image of the first really developed MantaMate prototype. It's got all these knobs on it, and it has an internal synthesizer that I designed that lets you, it's got like an internal digital synthesizer with envelopes. It had an Ethernet jack so that you could communicate with it over OSC messages on a network. It's like, it had all kinds of crazy stuff, because I just couldn't figure out what to cut out, and I couldn't figure out what to not let the person do, because when you plug it into a computer, you can write some software in Max, you can write something in SuperCollider, you kind of make it do whatever you want.
Right.
But with the modular, you can't do that. And one step I could have done is I could have said, I'm going to make some kind of interface that lets you program your own thing and then load that on. But that was a whole barrel of worms that I did not want to jump into. So I was like, okay, I'm going to have to decide what I let them do. And it was torture for me to figure that out. I think one way that Brian solved it really well was that he came out with several different modules that had different functionality for the mono, right?
Yeah, that's absolutely true. And then with the teletype, you can kind of connect them together and have them talk to each other a little bit too. Yeah.
Yeah. I feel like and really, I remember, Brian and I were both kind of working on this project at the same time, of trying to make our devices talk to a modular synth, or our USB devices talk to a modular synth. And he beat me to it by a couple of years. But I was very influenced by what he ended up doing, because I was like, oh, this is really smart. And really, when I saw how limited he was able to make it and still have it be so exciting,
Yeah.
that's when I was like, oh, okay, I can really do this. People aren't going to expect it to be able to do whatever they want. They want it to be a cool sequencer, or they want it to be a cool keyboard, right?
Yeah.
And once I could accept that, then development moved a lot faster. And then I was like, okay, now I just have to get the cool keyboard and the cool sequencer to work, which took me longer than I expected, but still worked out.
Yeah. Well, it is a lot of fun, and again, it has this kind of magical feel to it, and look, I mean, again, when it lights up, it's pretty spectacular.
It's funny, the way that it lights up is definitely the thing that makes it the most pain in the ass from a manufacturing perspective. Because it's like, the LEDs are actually glowing through the circuit board material, but then the circuit board material has to be a special kind that won't block the light. And, there's just no circuit board material manufacturers do not specify
opacity,
FR4
right,
for that opacity, right? It's just, there's all these, all these visual things that I really cared about the look of that make it so much more complicated than if I had just done an aluminum panel or something. But,
sure.
But I think it really, I'm happy I did it, though. I still feel like the design looks beautiful. But it's meant that I've gone with a different circuit fabricator for all 3 different editions too, because the first time, now that material's gone out of manufacture, and now I have to find another one, and then this other place won't do blind vias anymore, just all these different things. So
given that, do you have anything else in the works?
I've got another project. Basically, the ones that are likely to come out in less than 8 years are the ones that I've already been working on for 4 years. So I've had a project in the works for a long time called the Burl, which you can find some pictures of on my website too. It's still quite a ways from being released, but it's like my attempt to make a wind controller. So I make a whole lot of instruments. So there's actually a bunch of kind of one-off instruments that I've made for my own music that I've got all over the place on like shelves and things. But most of them, there's just no way that they could become a commercial product, because they would cost too much to manufacture in quantity, or they just involve too much labor, or they're just too weird and nobody would ever want them. But I started working on a wind instrument for my ensemble of invented instruments that I kind of conceived this whole project as. Okay. And I was like, we need a wind instrument. And that's my wind instrument has always been called the Burl. And it just sort of it's gone through tons and tons of changes over the years. And that's another one. I built the first version in 2009, I think. And it's just changed a lot. Now it's basically a wind controller, but it's also intended to work with the MantaMate. So I've been designing it so that it's a wind controller you can also easily plug into your modular. And it has a built-in synthesizer thing, which I've been working quite a bit on too. In a lot of ways, it's very similar to existing wind controllers. So it's a little hard to figure out how best to explain what's different about it. I kind of feel like a lot of my work ends up being it's like subtly, there's something very subtle that makes it very different, but it's like, how do I get that across? The wind instrument, one thing that's very different about it is existing commercial products tend to have the holes on the wind instrument are kind of like keys where they're digital on off, and it'll try to figure out what note you're trying to play by looking at the binary number that is made up of your button presses, right? So it's right. Your holes are either open or closed. But then there's a lot of wind instruments in the real world where that's not the case, and there's a continuous variation in how open or closed a hole could be, right? So think of the bansuri, Indian bamboo flute, or Chennai, double reed instrument. There's all sorts of instruments with just straight up open holes where bending the pitches using those open holes is a big part of the playing technique.
Right.
And I wanted to try to make that possible. So I've developed this wind instrument it's using capacitive touch sensing technology, much like the Manta, but there's sort of a mapping issue of how do you actually make it so that rolling your pinky off of that thing will actually bring you to the note you want and bend correctly. That's sort of more complex. So I've been working quite a bit on that side of things. And right now it uses this machine learning kind of neural net approach, where you can train it by saying, okay, when I do this fingering, I want it to be this note. When I do this fingering, I want it to be this note, right? And then you can say, okay, figure it out. And then it goes and tries to figure out what it's going to do. And then now you can play all sorts of patterns that you didn't train it on, and it'll try to make something up for those, right?
Wow.
And that's kind of really interesting to me, because what I feel like is really missing from conventional wind controllers is like if they look at your finger patterns and say, look and check it against the lookup table and say, okay, does this match something I know? You know, existing things like the UE or the Yamaha WX series or something,
right.
If they don't know it, then the note doesn't change, right? But in a real wind instrument, if you play like one fingering and then you move some finger that's not supposed to be a traditional fingering, maybe it gives you a slightly flat version of that original note. You know, maybe it gives you a multiphonic. Maybe it gives you some kind of crazy thing, right?
Right.
And I kind of really like the idea that there's this huge space, and there's, you know, some people's whole playing technique comes out of that, right? You listen to Evan Parker, it's like his whole technique comes out of finding these weird places that are kind of undiscovered on the saxophone and just, you know, figuring out where they are and how to get them, right? And I kind of wanted to make a wind instrument that had that depth in it. So that's the way I'm trying to approach it right now, is do this kind of training system so that it ends up filling all the latent possible space, right, with potential things, which could be pitches, could also be timbral, right, too.
Yeah.
So you can train on multiple parameters.
I was wondering, too, how dynamic of a system is this? I mean, is it going to lend itself to experimentation? Like you make like really poor, you know, you train it in sort of like a poor way specifically to see what kind of ridiculousness it might produce.
Yeah, I mean, that's a major concept of how a use case of how somebody might use it, I think. So, you know, it's basically totally dynamic. You just say, right now, you can't do it on the instrument yourself. You have to plug the instrument into a computer, and then there's a little interface where you say, I'm going to train, and then this is what I'm going to do, and it's going to give this output or something.
Right.
But you can just keep doing that over and over again, and then you can save the stuff. And what I'm working on right now is that then you just load those trained systems into the instrument itself, and then that remembers them. But, you know, the process is so easy that it's just like you could experiment 100 times and find all sorts of different things you could do, which makes me very excited. Wow. I don't know how many wind instrument players will care about it. You know, we'll see. It's a wacky idea that hopefully people will be excited about. But that's likely going to be the next Snyderphonics product, is as soon as I solve a few of the remaining technical problems and figure out how to do some things that I'm finding difficult for manufacturing things. If I can figure out how to do those smoother, then I want to come out with it.
Well, it's interesting because I interviewed Niall Steiner a little while ago about the development of the EWI, and it was interesting how the creation of that sort of led to there being people for whom that was their instrument. That was the expression. Yeah. You know, and this seems like this has the ability to do that, to literally become the tool, you know, the instrument for someone who becomes adept with it.
Actually, Niall Steiner is a really huge influence on me in a lot of ways, not just with the EWI and the EVI, the UE and UV. Also his Synthicon, and I don't know, he's a really interesting designer. So I've been excited about his work for a while.
Yeah, well, I'd have to say that one of the things that interests me is the way that he always found a way to make things organic, even at a time when it seemed kind of improbable with the technology available, you know?
Totally, yeah. And I mean, I don't know, you look at the original EV, right? And it's like, I don't know, you know, those original prototypes are cooler than what Akai came out with. So, I mean, it's kind of like, you know, they eliminated a few things. And, I mean, also those original things were synthesizers in themselves, not just controllers.
Right.
In a way that I find really exciting because they had their own voice, right?
Yeah, indeed. They're truly instruments, yeah.
Yeah, which is kind of it's a real problem I have sometimes in my own development of I have the goal that I want to make instruments. And ideally, I'd like to make things that actually sound like, have identifiable sounds where you can listen to a recording and be like, oh, it's that thing, right?
Yeah.
Everything I've released so far is actually a little more, you know, the Manta's a controller, right? It doesn't sound like anything. So I don't know how I can, I need to actually release some of my more instrument stuff, but you know, I don't know. I'm not living up to my goal in some ways. So it's like, I don't know. I feel like an electronic musical instrument should be self-contained and should have its own sound and should have a lot of constraints and limitations that make it the way that an acoustic instrument does. But it's so hard to hold to those ideals.
I hear you. Now, the other thing I know, just from some earlier discussions we have, the other thing I know that you're playing around with is with some VCV Rack development. We've had a lot of VCV Rack activity here on the podcast and in my studio as well. It's a pretty amazing platform. What do you got going there?
I'm super excited about VCV Rack stuff. I've seen a few different attempts to do that, like make a modular in the software thing. And I think it's really hard to do well. And I feel like VCV Rack's really pulled it off well, where it really feels like it interacts, modules interact in a really realistic, interesting way. You can do feedback. You can do all sorts of crazy things that I think of as being limitations of the software outside of a modular system. And it has of course, the amazing plus side that you don't have to spend $300 anytime you want another functionality, right? Now I want 2 oscillators. Oh, crap. So you can just click and add one. But also, like, looking into it, the development kit is really not too hard to get into. So I've been working with a little team over here. I've got a researcher named Mike Mulshine who works with me, and a couple undergraduate students at Princeton who are in the engineering program who've gotten excited about this too. And we're kind of working together to try to make a set of VCV Racks modules. One thing we want to do is we want to port the MantaMate to VCV Racks, which we think would be really cool, just because it does a whole bunch of interesting things. It, in some ways, it doesn't make as much sense. It's like, okay, a Manta already talks to a computer. Now VCV Racks would live in the computer anyway. But I feel like making it so that you could control the kind of things in VCV Racks with a physical controller of the Manta would be really exciting, I think.
Right.
So I want to do that. Also, I feel like right now it's a pretty open market where there's not a whole lot of people who've finished things for it yet, but there's a lot of people using it. So when I go on there and look around I just want more VCV Racks modules for what I've been doing with it. So I want to fill that need a bit. So we're working on a MantaMate port, but we're also kind of working on a few really crazy ones, trying to decide how to come out with these. One of them is basically ready, and we're going to release it in a few weeks. I don't know exactly what it'll be called, probably Squid Axon or something, because it's basically, I've been working a lot on trying to do synthesis using methods that are not intended to be audio synthesis methods, if that makes some sense. If you've heard of physical modeling synthesis, which I know you have, Darwin,
right.
Physical modeling synthesis is sort of like you take a model of how a physical system works and you have some equation that describes that physical system, and you set up your digital system to replicate that and create the output that it would create given a certain state that it's in. For instance, it would vibrate the way that a string would vibrate and tell you where, if you watched one part of the string, what would the deflection from the center point be? Right. I don't know. Probably that's not the simplest way to describe it, but there you go. But there's models of other things that are not acoustic things like a drum or a string. Science uses models for all kinds of behaviors. So one thing I found kind of interesting, there was a student in the electrical engineering department here who was telling me about how he's working on these models of how a neuron fires in his lab. And he was showing me how it worked, and we were both like, oh, I wonder what this would sound like. Because basically neurons spike, and there's different kind of inputs that they can have, and then in these models of how a neuron works electrically, certain input configurations will make them just kind of spike and then go down, right. And other inputs will make them oscillate, where they'll, spike repeatedly. And then how complicated the model is, like how realistic it is in certain ways, will kind of determine how that waveform works. And we got really excited about this, so we tried to prototype something up so that we could test it out, and we got it to make sound pretty immediately, which was amazing. Then we kind of developed that a little bit, and I came out with this model that is basically just like a little digital synthesis model of a neuron firing. And then the parameters, the input parameters for it, are all the physical properties of what makes neurons fire. So it's the membrane voltage is the output, and You've got a sodium channel activation and sodium channel inactivation and potassium channel, things like that are your actual input parameters, which mean absolutely nothing to us as musicians, right?
Right.
So, and I find it really interesting, actually, if those are your input parameters and then the model responds to them in some way, like how do you make music with it? And I find that to be kind of an interesting problem. So last year with Laptop Orchestra, we did a piece where this was the instrument that everyone had. And at the time, we just took a little Akai controller with some knobs, and there were 8 parameters, so we gave 8 knobs, right?
Okay.
And then we all tried to learn how to play it. You can't play particular notes, it can get different. You can kind of figure out, okay, this knob sort of makes it go higher. This knob kind of interacts with this other knob, and it's basically like a low-pass filter, but it also makes it go flat. There are all these kind of interrelated effects of it, which I found really interesting, where it's not like this is the filter cutoff. It's like this thing makes it noisier and makes it higher frequency or something, And it was really interesting to work with an instrument where the input parameters really weren't obvious or weren't kind of musically sensical, right? So anyway, we wanted to try to see what would happen if we turned that into a VCV Rack thing. So we made it, and it's really fun. You can kind of and you can even, feed the inputs back into the outputs and stuff, and it just makes this crazy, noisy, screamy sound. So we're hopefully going to release that. I'm just a little worried that maybe it'll scare everybody away from Snyderphonics VCV Rack's modules, because it'll be like, oh, okay, they make the totally weird, crazy stuff that I can't understand, but no one understands it. It makes no sense.
That's the point, right?
Exactly.
That's the plan.
Exactly. So, but that one's really exciting. So we developed that code, and then we've been kind of working a little bit on developing a base of code in this language called OOPS that we wrote here at Princeton. It's not a language. It's more an audio library written in C. And we've been trying to figure out, okay, so we made this Neuron thing as a VST plugin, actually. That's how we used it in Pluric. And then now we've made it as a VCV Racks thing, but we're also kind of working on making a little kind of a workflow where we can develop for VCV Racks and also develop for hardware as well, because we've got kind of these little digital brains that I made for modular synthesis, digital audio boards. We've been working on kind of translating it to the same, so I could also make just a little Neuron hardware synth thing.
Sure.
I don't know if I'll ever come out with those as products, because I don't know what the demand would be, but I guess people like crazy sounds and modular synthesis. But it's been really fun. It's kind of neat to be able to simultaneously develop for both of those things, right? So that's been really exciting to us. And I feel like that really would not have been easy like 4 years ago or 3 years ago at all. VCV Racks didn't exist back then, but even, we're also using the Juice platform for a lot of things, and it's just that makes things, developing software for VSTs and stuff like that, just so much easier. I'm really grateful for their development work.
Yeah,
it's an awesome platform to use.
Well, Jeff, man, we blew through an hour in an eye blink. It's fascinating just diving into your brain and also hearing all these different directions. It seems like, I don't know, man, it seems like you've got electricity by the tail here a little bit. It sounds fascinating.
Yeah, I'm having fun at least.
Yeah, I'm going to have to get out there and visit you, see what you got going in your crazy laboratory at some point.
Yeah, you're invited out to my workshop anytime, man. Come to New Jersey.
All right, I'm on my way. But with that, I am going to let you have the rest of your evening. So thank you so much, and have a great one, man.
Oh yeah, thank you so much. Talk to you later.
Bye. Many thanks to Jeff for talking about the MantaMate, the Manta, the Burl, the upcoming VCV Rack work. It all sounds pretty magical. If you get a chance, get over to Snyderphonics. That's SNYDERPHONICS. Check out Snyderphonics to see what all he's got going on. I'm sure that there's going to be a constant stream of fun. And if you get a chance, check out the MantaMate. I'm having a lot of fun with it. I want to thank everybody that's been helping out with the podcast. I especially want to thank all my friends at Synthtopia. Their support of the podcast has been really, really helpful. I also want to thank Cycling 74, my employer, and the people that give me a lot of flexibility to do things like this podcast. With that, I'm going to say goodbye to you for this week. We'll catch you next time around. Bye.